All right, so in 153, we learn how to convert between bases. Depending on the situation, you may be able to avoid having to convert to base 10 first before converting to whatever the desired new base is. That really only happens when one base is kind of I'll say a power of another. Like 8 is a power of 2, like 2 to the third power is 8. So going from base 2 to base 8 wouldn't be too much of a problem. Going from base 2 to base 16, base 32, and so on, anything that's a power of 2 would be okay. All right. But really, any other type of conversion is going to be somewhat problematic. So if I wanted to go from like base 3 to base 5, for example, I would want to stop off at base 10. So basically unconvert or change over from base whatever to base 10, and then base 10 to that new base whatever. All right. And that's really all this is saying here. All right. So if I want to take a number that's written in base 12, the first thing I would do is establish what the place values represent. So the first one is 12 to the 0th, 12 to the first, 12 to the second, and 12 to the third. All right. So that would be 3 times 12 to the third plus 5 times 12 to the second plus, well, E times, E is for 11, 12 to the first, and then 4 going multiplied by 12 to the 0th power. And for this, because the numbers can get a little kooky, I'll just pop it right in. So I'm just typing away here. It would be 12 to the first, which is just 12. Right. And then 4 times 12 to the 0th is just 1, so 4 times 1. And that gets you 6,040. All right, that's somewhere over here. That's not our final answer because that's in base 10. We want to now go to base 9. So the way we handle that, I'll just kind of do it off on the side here. I have my 6,040. I divide that by 9. Remember, there's a bunch of different ways to do it, but this is probably the way people land on the most as being the way they prefer. Right? So 6,040 divided by 9 is going to be 671 with some remainder. All right. So what I do is I take that 671, multiply it by 9, see what the difference was between that previous number and that new product. That's a remainder of 1. So that would mean that if I took 671 multiplied by 9 and then tack on a 1, I should get 6,040. Then I go 671 divided by 9, same progression. All right, so 74 times 9, so I'm dropping the decimal. That would be a remainder of 5. So 74 with a remainder of 5. Then I would do 74 divided by 9. That's going to be, so 74 divided by 9 is going to be 8. 9 times 8 is 72, but I'll type it in there anyway. That's a remainder of 2. And then 8 divided by 9, 0 times with a remainder of 8. All right. So again, we read it from bottom to top. So in base 9, we're looking at 8, 2, 5, 1. All right. So if I want to do binary to base 8, that's actually where our shortcut approach is going to kind of come into play, but I'll get to that in a minute. If I were doing it, I'll call it the standard way. We identify binary to base 10 is pretty straightforward because you only have zeros and ones. So we have our 2 to the 0th, 2 to the 1st, 2 to the 2nd, 3rd, 4th, 5th, 6th, and 2 to the 7th. All right. I basically just kind of ditch anything that's got a 0. Kind of pretend it's not there. All right. And then multiply the resulting power of 2 by 1. All right. If you want to go a step further, because doubling numbers isn't really that challenging. So even if I didn't want to scribble out this stuff, which I can kind of undo for a sec, I'm going to show you this is the same as 1, 2, 4, 8, 16, 32, 64, and 128. All right. So then I would say, okay, well, I don't need anything that's got a 0. Oops, it jumped away on me. Okay, so that would be these two guys. So, all right, I have 128 times 1, 128. 64 times 1, 64. All right, so it's this and that. The next one would be 32, 16, 4, and then lastly it would be a 1. So then it's just a matter of adding them up. All right, so 128 plus 64, so 192. All right, then 224, I think, and 240, 245, maybe I'll just double check. Yep, 245. So that's base 10. Right, that move of assigning powers to it gets you over to base 10. So now we want to take that number and get to base 8. So 245 divided by 8. And this is the basis of our shortcut, is that dividing by 8 is the same as dividing by 2 to the 3rd power. Right? So that's going to kind of get us going in the shortcut method, and I'll show you that in a few minutes. Or actually, I think it's the next video, but we'll see. So 245 divided by 8, that gives me 30 with a remainder of, that's going to be a remainder of 5. All right, 30 times 8 is 240. To get to 45, you need 5 more. So take my 30 divided by 8. All right, going to a larger base seems like it would be like more challenging, a lot more challenging. And I suppose if you couldn't use a calculator, that might be the case. But the numbers get smaller a lot quicker than, for example, going into base 2. So it's kind of nice in that regard. But that's going to be 3. 8 times 3 is 24 with 6 left over. All right. And again, 30 divided by 8. All right. 3 times 8. Then you could do the 30 minus the 24. Right. Then the 3 divided by 8 is 0 times with a remainder of 3. And again, bottom to top. So 3, 6, 5 in base 8 is what this binary string would be equivalent to. So yeah, that's all down here. We'll get there eventually. And so let's save that and upload it. So you should be able to tackle the problems in 153.